All right, so we're good to go. We're recording. We're live. Um, Let me see. Let me just kind of rehash what I was already talking about. So, um, just gonna go to D2L quick so we can talk a little bit about housekeeping, um, and have this in the recording as well. It didn't save my. Oh well. Okie doke. So, software engineering. Okay, so a couple things. On Friday, we'll be having the candidate from I forget where the guy's from, but seems like a really good candidate. More of a networking guy, from what I understand, and some security issues and things like that. But he'll be giving a talk on Friday for our class. So if you come, it's extra credit. I'll have a sign-up sheet. I've assigned. So homework 5 is due Friday night, 7th. That's alpha, and you know all about that. I assigned a homework 6 beta, which will on 412, which is 412 is Wednesday next week. We'll be planning out. I'm going to sit down with each team. My idea is I'm going to sit down with each team because by then I'll either have looked at your alpha or you can show me it at the time. And I want to create a product backlog and where we're going from here and really get a full, firm plan for how to finish the project. And that's what beta planning is going to be all about. So I talk a little bit about the beta requirements in here. Feature complete, content complete, the difference between the two. That'll actually be due near the end of the month, but it's assigned now, and we'll be talking about it a week from today. So the other thing is I put a homework 7, which is actually an individual homework. That's technically due before the homework 6, which is a little weird, but yeah, it is what it is. This you're using the object pool stuff we're talking about today, and you're using strings. The cool thing about this is it's assignment from my old days game programming, where we actually would do things like this. We would create an object pool of strings to save us memory overhead. What the heck just happened there? I don't know what's going on. I lost it. Oh well. Huh. That's weird. My in-app browser just suddenly decided to crash. Whatever. It's not that important, I guess. But anyway, that's your homework 7, and that's due. Wow, it's really flipping out now. Now it's going to the thing. I don't know. Anyway, so that's that, and yeah, that's about all I got for housekeeping. Oh, we also I'll make an announcement, but we also don't have class at all on Monday. I've explained in my data structures email, but that's the day that my son gets his big brain surgery. And we're hoping for the best because if it succeeds, things will be a lot different for me in my life as far as dealing with all these medical issues. So we're really hoping for the best, and that is on Monday. And I can't even do virtual class on that day because I'll be sitting in a hospital on pins and needles, hoping for the best. So I'll see you guys on Friday. Monday we don't have class, and then Wednesday we have class, and then of course we have class Friday as well. And from there on out, everything hopefully is normal. I mean, if not, I'll let you know. So anyway, this is we're going to go over object pool pattern today. This is not a Gang of 4 pattern, so this is sort of above and beyond the Gang of 4 stuff. And It's just what I try to do here in the content is just giving you guys some patterns that are actually used in the industry, which is where the MVM comes in, and MVC, and now object pools. So there's a lot of different examples you can choose to use for object pools. One I showed you was the string example, which you're going to be messing with for your homework 7. Another one would be databases. So the idea would be that we want a limited amount of connections per database, and those connections can be set up ahead of time. That's the whole thing about object pools, is basically you set your objects up ahead of time. So at load time of the system, you create a bunch of these things and they just sit there, and then when someone requests that resource, the object pool gives them that resource. So it's a way of managing your resources cleverly so that the instantiation time is kept to a minimum or just completely disregarded because the thing is already created. This is again, this is from Sophomore Consulting. They had a presentation on object pools that I'm borrowing, using whatever, but they in turn took a lot of their stuff from Wikipedia. That's what this slide is from. And it talks about object pools being just basically a set of already initialized objects. So you basically got, the way this is basically you've got your pool here of all your objects. Things are requesting out to get these objects. And there's one request, and then here's another request. The clients are over here. So these are that's the client, and the pool is here. So the pool holds these objects. The client says, I need a new object. Pool says, okay, I'll give you that resource. You might have to do something like acquire resource or something it might be called, but you call into the pool to get it. It can give you a nice performance boost because sometimes it takes a lot of time to create these instances. The flowchart diagram for this looks like the following for databases. So in a database, you would say, okay, I'm going to get a connection. First of all, if my pool is empty, that's fine. I'm just going to have to create a brand new connection. But if it's not, and it's usually not going to be, you're just going to get an existing connection, return it. So that's how that works for the database example. And actually, there's a bunch of databases that work this way. That's why they chose the database example. To the clients, it doesn't really matter. You're not going to see a big difference, but underneath, this is how it was implemented. So for example, here we're saying we have n simultaneous connections that are allowed to the database. That's plugged into the pool, and then we can request those as a client. JDBC is one example of this. This uses the data pooling, or the connection pooling concept to a T, basically. Now, when you're using JDBC, you might not have realized that this was all in this just like object pool, because to you, you just get a connection. Now, it's true that you have to close the connection later. When you close the connection, that's where you're essentially releasing the resource, and now someone else can grab it. And by the way, if there's any questions, shout them out on chat or drop me a line, however you want to do it. But this is pretty straightforward stuff, I hope. So the intent, obviously, of this pattern is to permit reuse of objects over and over again. So, client comes in and says, okay, I want a new database connection. And bang, I got it. It goes and uses that. Maybe it does some queries. It does whatever SQL commands or whatever it's going to do. It's done with it, sends it back to the pool. Another client comes along, says, I got to do the same kind of thing. So I'm going to get this from the pool, pulls it in, does its SQL commands, whatever, then it closes it. So that's how it's intended to work. This is the UML diagram, and it shows you, this is what I mean by, they might not call them like news and gets or something. They're going to call them acquire and release. So acquire gets that new resource, release releases it. Release is basically you're done with it. Acquire is you're about to start using it. So an object pool. Now the thing about it is, the object pool as the main participant is going to have to be managing this. This means that it has to monitor these connections, perhaps routinely. If you're in a ticked environment of some sort, and you have to make sure that they're ready to be reused by the next state, etc. So essentially, these things are cached. They're ready to be used. They're ready to be loaded up. So the client obviously is making that request. Once the object pool gets the request, it has to search for an available resource. If it finds one, it returns it. If it doesn't find one, then it has to new it up and actually create it. Now, here's an important piece as well. The clients do not need to be aware that they're sharing these reusable resources. In fact, all it has to do is close that out after it's done using it. It just has to say it's done using it. So we get a pretty significant performance boost by doing this. Newing takes a while. I'm actually on a project right now where we've got, for the drone project, we've got a map layer, which is showing a map of the area the drone is flying over, and we draw things on that map. In this case, we're drawing waypoints, so like little points that the drone has to go to. We've noticed a performance issue in the creation of these objects once we get past about 20 to 30 waypoints. It turns out that performance is from the creation of these bitmap objects in the actual rendering layer. So it costs a lot to create these things. So we're actually using, and this is why it's kind of cool we're talking about this now, we're actually taking this object pool pattern and using it. Like literally, that's one of the things I'm working on right now. We're going to have a cache system that at load time creates a whole bunch of these things and then just uses them later. That means the load time is affected. So what happens is your load time might go up, but runtime usually goes down. So your runtime speeds, your worst performance, I should say. But your runtime speeds, your wait times usually go down. Your delays usually go down. So that's a very useful property of the object pool. And this just states the rest of what I just said, but there's a whole bunch of strategies here, well, 3, namely, to handle requests when there's no spare objects in the pool. First of all, we could fail to provide an object, return error to the client, maybe do an exception or something. We could allocate a new object, increase the size of the pool. In this case, you might want the overall system to have a high watermark before they're allowed to do this. We could also block, in a multi-thread environment, we could block that client until another object comes back that's useful. Now, this has to be done with extreme caution, because as I mentioned, I think in my OS class, which you guys didn't get, unless you were in OS, you didn't get the benefit of hearing about, but in multi-threaded environments, generally speaking, you don't want to do blocking calls, because blocking calls are just that. They're blocking. It creates unresponsiveness. So if you're doing it on a UI thread or something, that's bad. So you want to be careful with this last one. In certain situations, you can get away with it. But if you've got a heavy UI environment, you might not be able to get away with that. Just because if you block everything, then the users are going to know that, okay, the performance is now degraded and it's bad software kind of thing. So you might not want to be doing that a lot. Um, so when we're returning these objects to the pool, the object pool may need to reset them. The clients shouldn't have to worry about that. So, for example, when you're doing the way this would work is when your client closes down object would happen, then the object pool would be responsible for resetting. And now a new client can get the object back. So there's some work to be done when you release those objects. So from this in turn was more slides from Kircher and Jane. So basically to implement this, you have to identify the resources you're going to use, determine the size of the pool, define some sort of interface, provide for cleanup resources, and define failure strategies. And I'll go into most of these when I start showing you the code in Visual Studio. So there's a lot of examples of object pools. .NET uses it for threading because it has a certain number of predefined threads that are allowed to be instantiated. You can create thread pools in the concurrent executor service routine of Java as well. There's some related concepts here. And actually, one of these related concepts is unique ID, which I'm going to cover briefly, and that's what you're working on for the lab. So in a pool cache, object cache, this is basically just an object pool, except we call it a cache because they maintain state. So the state of the object in the cache can be maintained. It doesn't have to be cleared every time. These are usually singletons, which is a related pattern, meaning that there's usually one of these object pools per type. So it's like we're using the singleton pattern here. Unique ID. So this is what you're going to do for the lab. It's just an extension of the object pool, which is why it's a good lab assignment, because I can give you the object pool code, which I've done. And what all you're going to do is add an ID to the object. That's assigned on creation and stays for the entire lifetime. So that's why I said the lab is basically just using the code provided, change it to the unique ID pattern. Every time you go in there, you assign a new ID. So that can count up. That can be like a static, a static singleton that just returns an ID, or just a static global that's just a number that is just kind of a dumb number that just goes up by 1 each time. That is then a unique ID, because if you go in there and you create all your objects, it'll reference that static variable. It'll start at 1 or 0 maybe. It'll go to 1, 2, 3, 4. Every time you get a new one, it references it with whatever the current value is, and it adds 1 to it. And we'll talk about that a little bit more in a second here. Here's some references for where this stuff came from, where these slides came from. So let me see how to, okay, so I haven't tried this yet in Collaborate, but it can't be too hard. I think what I need to do is share my application. Yes, I'm going to share. Okay. So okay, so I turned my video off, but I think I still have audio. Can one of you guys let me know if you can see Visual Studio? Okay, cool. I haven't, and hear me? I haven't done this in this way before, so this is kind of a little bit of a test. Okay, cool. Thanks, Justin. All right, so this is the code that I've given you. I don't know why this is being included twice, but all I've done is basically just to give you an idea of how to do this. I create a new C++ project, console application I selected in the wizard. This is in Visual Studio 2015 community. And then all I did was I took the code that I've got posted and I pasted it in here. In fact, you should be able to paste basically exactly that. The only difference is you'll have to get rid of one of your includes. So this is the code that I posted. And as you can see, it's literally just one file called objectpool.cpp. And it's running right now. I'm going to stop execution though. So here's the object pool. First of all, we've got a resource class, which is just a value. It's just an integer. It's really just a dumb class. I mean, all it is a integer. It's got a get and a set. This is the object pool, which is going to be the singleton. It's got a std list, so this is using STL's list, which is std, standard template library. And it's just a list of resources. Get instance is, this is just singleton stuff. This just returns the instance. If it is 0, it creates a new one. If it's not 0, it returns the existing instance. So this is singleton. We've covered singleton already, so that should be hopefully pretty straightforward. Now, when you do get resource, here's where the fun starts. If it's empty, it has to create a new one. If it's not empty, it goes to the front of the resources list, pops it off, and returns it. Pop is a list primitive that you can use, a list function that you can use. Return the resource. This creates the singleton, instance equals 0. So we say get our object pool, and now it's going to get 2 resources. We call get resource. Well, resource doesn't exist yet, so it's going to create it. We set the value to 10. We call get resource. That's going to be resource 2. And then we return them. But now note that now that we've returned them, they still exist, so they're just going to reuse them. But because of the fact that we want the object pool to reset these things to be basically new objects, it has to reset them back to 0. That's what happens when you do return resource. It does a reset, right? So this reset here resets it back to 0 to prepare it for the next usage. But here we do get resource again, but this time, here's the difference. This time, it's not going to call new. You know, it's not going to call this, or not that one. It's not going to call this because there's resources that already exist. So we're going to do a reuse existing, get the one off the front because we've already instantiated it, and return it. And then we're just going to set it. Well, here we just print out the value of it, right? So we're just going to print out and it's going to end up being 0. Now, one unfortunate piece is that I think if I do start debugging on this, since this isn't C#, yeah, you're not going to see the results of that because it's in a separate application. Let me show you. I think I can do that pretty quickly though. I can just go back here and stop sharing that and then start sharing on this thing. So that's the so you can see that it creates the new ones as 10 and 20, but now it's getting new ones again, but these are going to be set to 0 because of the reset function that was called. So pretty simple idea. I mean, it's definitely not all that complex, but but I just wanted to give you a flavor of it before you start the lab. So the lab, I don't know, this browser was acting a little goofy for me earlier, so I'm not sure what it's doing now, but let's find out. Wrong password. Okay. So what I did was I put up here a lab. Unique ID lab 11. I don't know why I called it 11. I don't actually think it's 11. What the heck is it? Week. Let's fix that. This should be, I need a Dropbox for it too. So this should be lab week 10. And in my contents section, I'm going to change this to just say unique ID lab. Okay, so this is basically just saying take that object pool stuff that I already gave you, make it into unique ID. Now that's going to be really easy actually. I mean, this is not a hard lab to do because basically you've already got a resource, right? So your resource, the class that I showed you before, you're just putting another number in there, and that's just your unique ID. Now granted, you're going to need some sort of global or something to keep track of what unique IDs are. You could be fancy and you could get a random number, but of course if you get a random number, there's no guarantee you're not going to get the same random number twice, so that's probably not the best way to go. If you would do that, you would have to be slightly more complex where you see that, okay, that ID exists already, so you keep calling random or something like that. You could do it if you want. It's kind of a slick way to do it, but probably the other way to do it would either be to have a singleton or a global that just has a count and then just assigns them each time. Once it's assigned, once it's created, it just stays with that object for its lifetime. So the ID of the object, when it's created, like that, what I showed you in the code where you've got two resources. The first resource, you get it, it's going to have a unique ID. Then you release it. When you get it again, it's going to have the same unique ID. And so you can use the code that I've provided for doing that, which is all just in one file. It's here. It's called Object Pool Code for Lab. And I've got the slides here as well. So, all right. It's 10:30, so class is basically done. Any questions? All right. Well, I will see you guys on Friday for this class. We've got the teaching presentation of the new candidate coming. We'll have teaching evaluations for you to say what you think of them, and I will also have the extra credit sign-up sheet. Your lab is due Friday night. It shouldn't be a very tough lab, so but don't put off on it, so you get it done on time. And if you need me or anything, feel free to email me. Otherwise, we're good to go. All right. We'll see you guys. I'll be posting this as well.